The loads can't be controlled to operate the same time or separately, like your headlights, your brake lights, right? You turn your headlights on, both come on. That's parallel. You turn your brake lights parallel. You step on the brakes, your brake lights come on parallel.
You recording?
Yeah, I'm recording. Thanks. It's right here. It says connect the two lamps in parallel, and basically how we do that. Somebody tell me how you do that.
Go
Open it up.
R1, I mean 2 to R1, and then 11 to, what is it, 20?
20. Yeah, like a 20, but actually a 2.
Yes,
Like
2. And then from 3 to the R2, or the 6, and then the 12 to the 4.
exactly. And that's a parallel circuit. Now look how you got this. You got voltage coming from the battery, going through the circuit, going through this leg individually, back to the ground side and back to the battery. And the same thing on this one. You got current running through the battery. What flow is this? I'm going this way, the flow. Remember, the long arrow is positive, the short is negative. They place. They symbolize the place in the battery. So a long one is positive, short is negative. So I'm going this way. What flow is that?
Flow.
Huh?
Current?
No, not
Conventional?
conventional. Thank you. Yes, it's conventional. So I had current flowing through the battery, going this way. Now it's going through the second leg, going through this light to ground and back to the battery. So that means if this one blows out, this keeps working, and vice versa. That's the advantage of having a parallel circuit. Let's go to the next one. It's the same. It's the same thing. Connect the 3 lamps in parallel. The same thing we just did.
Guys, what's it called again?
What's your question?
A conventional flow?
Yeah, it's conventional. The current is conventional in this. It's showing conventional. Uh-oh, I did something wrong. Anybody see something I did wrong?
The 3 to the 6, it's not touching, is it?
Right, this one is not saying it's not connected. But you see it's not connecting. These two still lit up. Right? Explain what we did earlier. This one's out, but yet these two still light. Oh, come on. This is what I said earlier. Talking about earlier. Yeah, come on. Come on. What's going on here? There you go. Now they all on. See? Okay, I go to the next one. If you cut the wire between points 2 and 5, like I just did, will lamps 2 and 3 still be lit? Yes or no?
Yes.
Yes.
Yes. Because I just did that. Ah, this is a good one. Remove the connector between 2 and 5. Okay, I'm trying to figure out. This is 2 and 5, right?
Yeah, just click on it and then click the X, and it'll erase it.
Oh, okay. Now, remove the connector between 2 and 5 by clicking on it. Oh, I should have read it. And connect the ammeter between these 2 points. Now, here's my ammeter. Okay. Now, how do I hook this up? The meter.
You get one of the terminals put on number 2, and then you get the you put the positive on number 2, and then the negative on number 5.
But you're on voltage. You need to change it to amperage.
Okay. We gotta do
Your
what?
your lead has to change to amperage.
Okay, so I need to move. Which lead I need to move?
The red one.
Okay, that's good. Now what I need to do with this?
Move it to amperage.
Turn it on.
Then hey,
Turn it on.
it's 6.
Yeah, to the A. There you go.
Exactly. Let me see something. Now you
get
see,
negative.
now this is what we talking about. This is what I was talking about earlier. You saw us in series. There's no wire here. We talked about this earlier. There's no wire. That means current actually going through this way, through the lead, into the lead here, through the shunt meter, out the lead here, back through the tip, out through the bulb, the ground. That's what I mean by.
You're giving it power.
That's what I mean by series. That's what I mean by it's in series. You connect the amp meter in series, not a voltmeter. You can't do this with a voltmeter. You only can do this with an amp meter. Now it says remove the connection between 2 and 6. Ooh, let's put this back. Between, what's that, 2 and 6? Oh, 3 and 6, 3 and 6, this one right here. Remove that one. Just out of curiosity, what should the amperage read on this?
12 volts.
No amperage.
2, 6, 12, 1.
No.
3 amps.
3 amps. Remember, we got 12 volts.
Oh, that's right. I'm doing serious.
Yeah, you're doing series, yeah. You got 12 volts, 4 ohms. According to Mr. George Ohms, it should be 3. I think it was George Ohms. Probably got the name wrong. Probably got his name wrong. So, hook this over here. Yeah, Ohm's law is right. 3 amps going through the circuit. Next one.
See, that's why I get it wrong, because I'm always trying to do it before you guys. I'm going to wait a little longer now.
Trying to rush. Next one. Now we're going to do this one. Right, 4 and 7. We're going to remove it. And what should we get? How many amps should be in this circuit?
I'm going to stay quiet now.
2 amps.
2 amps, exactly. Now, does anybody understand how we getting that? This is all from a previous lesson. Do you understand how we getting this? Anybody want to ask a question?
Following the Ohm's law.
Yes, we found the Ohm's law theory, yes. And we confirmed it, and the ammeter just confirming the math. Remember I said the math is just a concept. You don't use math in the car. You don't use math on car, it's just a concept. In reality, you're going to use a meter. Right? The math just proves the point. Understanding how to use this meter. Excellent. Let's go to the next lesson. Oh, what is the total current through the circuit? Oh, this is good. Oh, they got a clamp now.
Hold on.
Now, let me see y'all do this without the meter.
6, 1, 11.
6, 3, 2.
11.
Does everybody agree with him? Did anybody have anything different? Everybody agree?
I agree, but can you do it with the clamp?
Yeah, I'm gonna do it with the clamp in a second.
I
See-
agree with that's 11.
11. All right. Let's see let's put the clamp on it now. I got zero this out. It's already zeroed out.
Is
Now-
Mario the close?
Now, where should I put the clamp at? Here or here?
Positive.
Positive. Oops. Hold on. How you? Come on now. Come on.
Put on the horizontal on top, on the top side. Right there with a right there.
Yeah, it's what it was is you see that little cross section right there. That cross section got to go on the wire. See it? See it's coming down. See it? You see that little like cross?
Yeah.
Oh yeah, yeah.
Yeah, it had to go. I think it had to go on the wire. See, now it goes on the wire. What's wrong?
You gotta change it to 20 volts. Or 2 volts.
Oh, we got
I'll
11.
try 200 milli. 200 amp.
We gonna put on 2 amp?
Yeah. No, it's a 2. It's a 2.
That was a 2.
The 2 volts. Oh,
Yeah.
what? You see,
So
that was the
20.
confusing part we did it last time, remember?
200. We put it on a 200. The one on top?
On the 200 millivolts?
Yeah.
Don't you have to divide by 10 because that's the conversion of the current clamp?
Yeah, because the clamp. See this clamp right here, right?
Well, you,
And it's
Yeah, you
it's 10 millivolts for every amp.
so you gotta switch right there. Go to the 1 amp, right on the next one on top, on the clamp.
No, this the bottom one's still good.
No, you go to 200
Yeah.
millivolts.
This is good because when you convert it over, it's 11 amps. Right here, that's a good reading.
Yeah, every 10 millivolts is 1 amp.
Yeah, every 10 millivolts is an amp. So 11, it's right here, 11.
So you take out the decimal.
I mean, see, cause you know what? In reality, this you see how it connects right there. You can hook an amp meter on the positive side, and I should be able to hook it on the ground side.
And then after a couple of beers at night, it even gets harder.
Yeah, that's the core. That's the only thing. That's why I don't really worry about the red that much. On the test, I would like to see I get a 70 or higher. But if I would have did this and it marked me wrong, I wouldn't even think about it because technically it's supposed to go here too. All right, you guys find the right spot, which is here for them. All right, let's go to the next one. The total current is 11 amps. What is the total resistance in the circuit? Uh-oh. Figure that one out now. We had 11 amps. So what's the resistance?
1.09.
What is it?
1.09.
1.0.
I thought you were gonna jump the gun anymore. What's going on?
he can't help us. So how he did that was, you said 1.09? How he did it was this math formula here. So it's going to take, oops. You take the 12 volts, which is this, and divide it by my 11 amps that we got from the previous example. 11 amps we got from the previous example. Oops. and divided by 11 amps equals 1.09 ohms. That's how we got the Now, next, the voltage across R1 is now R1. What's R1? Oh, R1. Now, do we really need to have a voltmeter for this?
Not really.
Not really. But now I'm gonna hook this voltmeter up. This is actually a test question too. How is this hooked up?
In parallel.
In parallel. The red lead goes where? Where does the red lead go with? Now I gotta call the bar today too.
I'm sorry, what are we trying to do now?
Hook the meter up. I was just thinking, I gotta call the bar. We about to go back. We probably go back to school soon. Our machine is locked up. I gotta call them today. Last time I was down there, it was locked out because he haven't been using it. And we're a star station too. We probably lost our star. I just got the station to be star, and we probably lost it now. You can't be star and don't do no work. They take it from you. Hope they be considerate and understand that we're a school and it's been closed for a year. Gotta call it. Anyway, how's it hooked up?
Red on number 2.
Who is that? Who is that?
That's Eric.
Eric, red on number 2, right here. All right.
Yeah. You have to remove also the connection,
2-0.
the black connection.
Remove this.
From 2 to 6, remove that black
This one.
connection. Yeah. Because I don't think it'll read it, right? Or will
No.
it still read
That's
it?
that's good. But you see, right here, I'm trying to remove it. It won't move
Oh,
because
okay.
you know why?
Yeah, 'cause you're going on.
So you're on amperage, sir.
You're going parallel, not.
Yeah. And look at this. Yeah, right. We going.
The fuse.
Yeah, we going parallel. We going parallel also. And guess what? Robert just pointed out something. I forgot to do. I just told you about this too. And I said, well, most meters don't work. I just did it after I told you about most meters don't work. I still got my amp probe. I still have my amp probe. I still have my lead in an amp socket. If I hook this one up, that fuse is gonna pop.
Look it up, mister, so we can see what happens.
I don't think. Let me see it. I don't think nothing happened in this one. Oh, you see that red?
What?
You see it just pop. I just blew the fuse. You seen it?
You know, on top of the ohms little symbol, that's the fuse. You gotta hit that little bar.
Oh, wait, on top of the ohms. Here?
The
Right
bottom,
there,
this
no,
bottom.
Oh, this one.
Go
Okay.
down.
Right there,
Oh,
right there.
okay.
Now change the lead.
That's a good point Robert just pointed out. And I just mentioned that to you. I said most meters in the shop don't work because we do this, and I just did it. It's just a force of habit. Anytime you use an amp meter, right after using the amp meter, you're supposed to take this and take it out that socket. Are you going to do what I just did? That was a good example of how that fuse popped. That was pretty good. Thank you for catching that, Robert. That was good. And that's the reason why most meters don't work. Amp meters don't work because of that.
I blew out so many doing this Electude. I don't really know what happened.
I see somebody doing in the classroom. They just got their meter, and I heard this big arc. I said, uh-oh. I said, dude, you hooked that across the battery? He said, yeah. I said, look at your leads. Lucky he only popped the fuse, though. He just got that meter, too. All right, so now, Eric, you was close, Eric. What you want to do is, you want to make sure I got the leads right. I want to take the black lead and go here to the ground side. And
5 and 8?
say it again.
Is that 5 and 8?
It's 5 and 8, yes. Anyone's asking for? Yeah, 5 and 8, yes, it's 5 and 8. And take this red lead over here. That's parallel across the load. So this one load here is dropping 12 volts. What the voltage across R2 is, it should be what?
12 again.
It should be 12 again, the same test. Just a different. Look, even though the resistance changing, look at that, you can see the resistance. This is, oh, come on, you son of a bitch. This is 2, this is 4. Different ohms, but the voltage drop is going to be the same on the parallel circuit. See that? It's going to be the same on the parallel circuit. That's the rule. Any load in parallel to the battery, as long as there's no resistor in series to that load, it should drop source voltage. So it's going to be 12 again. And obviously, we really need to hook the even though it's a different resistor, 6 ohms. But guess what? It's still gonna drop 12 volts because it's in parallel. Delete it. Oops. Because it's in parallel. All right, now let's get to the other one. Next module.